A table shows the size in thousands of an animal population at the start of several given years. Now you're going to have an X and a Y. So typically with these time series types of graphs, we let the year, like the time, be the X, and then the population could be the Y. So if you just go to Desmos, we can plot this data. At desmos.com, click plus to add a table. Now, you could put calendar years as your X values, and then put your populations as the Y values. You'll want to click the magnifying glass in the lower left in order to zoom to your data. But let's see where it takes us. It takes us to between 2000 and 2020 on the x-axis. That means we're really, really far away from the origin of the graph. And that's not ideal in many cases to have a graph like that. And you could type in the command for regression, which for an exponential growth type of problem, it would be y1 tilde ab to the x1, and you get your best fit curve. And that's all fine, but it's really far from the origin, and the a and b values that you get may not be nice. See, that a is times 10 to a power of negative 59. It's really a nasty number to work with. What this problem asks for is, it says, let your time be years since 2004. So they don't actually want you to put the calendar years in. Instead, they want you to use the numbers 0, 1, 2, 3, and 4. Okay, so what that'll do is it'll make the problem easier to work with. And it'll move our graph like back toward the origin. So let's try that instead. We won't use these. Okay. Now we see our graph is more reasonable to work with. And our regression constants are better to work with as well. In Desmos, you do have to click log mode. Calculators and WebAssign are going to use log mode. So this gives us an A of 2.38208. Let's copy that down. All right, our goal is to create an exponential growth function. So those have the formula y equals ab to the power of x. So we just have to plug in our a value here, and our b value goes here. And then raise that to the x. You can check your answer just by typing the formula that you think it should be into Desmos. And you can see if your function overlaps with the existing regression curve. It does here, so it's the right formula. You could write parentheses around these if you want. But notice in this problem, they want t to be the time and n should be the population. So we want to change our letters. Let's change our letters to represent the quantities in this problem. So instead of y, I'll use n. Instead of x, we'll use t. And that'll do it.